All right, this is some help for 5.4 Mosh Pit Gas Laws Intro, Notes, and Practice. You're going to watch the video and then use the video to help you fill in this table. So I'm not going to go through that part, but let's read this next part together. After the video, complete the rest of this worksheet. A key is posted, but try on your own first. So the new idea here is that direct and indirect relationships. Variables are simply things that can change. When two variables affect each other, cause changes in each other, we say they have a relationship. For example, the relationship between the hours a person works and the money they earn is a direct relationship. If you increase your hours, the money increases. If you decrease your hours, the money decreases. However, the relationship between hours worked and amount of free time is the indirect relationship. Increase in hours worked leads to a decrease in your free time. So here's a summary of that in this table. It says in example 1, where the hours worked and the money earned, an increase in one thing leads to an increase in the other. So here they both increase. Or a decrease in one thing leads to a decrease in the other. So here they both decrease. If they both do the same thing, then it is a direct relationship. On the other hand, in example 2, the relationship between hours worked and free time, an increase in one thing leads to a decrease in the other. So they're not both the same. That is an indirect relationship. If one goes up, the other goes down, or if the first one goes down, the other one will go up. So now we're going to return to the relationships between the variables that affect gases, which are N, the number of particles, P, pressure, T, temperature, and V, volume. Reading along with the worksheet. For each situation, predict increase or decrease. For increase, I guess we're using a blue, and for decrease, we're using a red. Remember to think of the molecules as dancers. In the column on the right, over here, you're going to circle if it's a direct or indirect relationship. So number 1, a balloon is put in the freezer. So here's a balloon. We put it in the freezer. So temperature is decreased. What will happen to the volume of this balloon? Remember, volume is like the size of the dance floor or the space that it's taking. So if I decrease temperature, we also should remember temperature is like the speed of the molecules, speed of the dancers. So if they're dancing slower, are they going to take up more space or less space? And if you think about dancers bouncing around and they go slower, they're probably going to move around less and take up less space. So it will decrease the volume of the balloon. The balloon might shrink and shrivel. So now I have to look to decide the relationship between temperature, volume. Is it direct or indirect? I look at one decreased and the other decreased. Since they both decreased, that is considered a direct relationship. All right, let's jump to number 3. A container of soup is heated in the microwave. Oh no, we left the lid on. What happens to the pressure? So there's some gas above the soup and the lid is on tight. So if we put it in the microwave, that will increase temperature. Remember, that's the speed of the dancers or the speed of the molecules. And so if they start to move around faster, will that increase or decrease pressure? Well, pressure is collisions. So since pressure is collisions, if they are moving around faster, they're going to collide more. Just like your mom or a grandmother, aunt might say, like, slow down, kids, you're going to get hurt, right? So that will increase the collisions or increase pressure. Once again, even though It's a little different than number 1, but since they're both the same, that is considered a direct relationship. Now let's look at number 4. An accordion is pulled open wider. That's this instrument over here that you see, this man playing. If he pulls it wider, he makes more space inside of the instrument. What does this do to pressure inside the instrument? So he's increasing the volume, which again is like the space of the dance floor or the size of it. And what will that do to the number of collisions of the particles inside of the instrument? Or what would that do to the dancers if they have more space to bounce around it? Well, that will be, remember, pressure is still collisions. So it seems like if you have more space to bounce around in, you're going to hit each other less. So that will decrease the number of collisions. So here's one where it's different. We have an increase in the volume leading to a decrease in the pressure. So since those are different, oops, I tried to change. Since those are different color and one's increasing, one's decreasing, that is an indirect relationship. All right, try to finish that and then submit to Schoology. Now I want to give you a little intro to the lab because you're going to use direct and indirect on the lab as well. So to do the lab, which is the next assignment, you're going to go to Gizmos, which is again through Clever. So here's my Clever, the letter C here. See it moving? Okay, so you tap Clever. You might have to log in if you haven't already. If you have, you might not need to. You'll scroll down and then you see Gizmos here. Tap that. Then find your class period. And then you will see our week 5 labs. I guess I don't really have it set up, but I'll make sure that it's on the top. And you're looking for the Boyles and Charles Law Lab. And that is written on the assignment clearly in case you forget. But I just want to point out, remember what I see, what it means. So I see over here on the side a temperature gauge, T with the purple. I can move that up and down. I see mass. Now this mass is referring to the amount of weight put on the top of the gas. So that's actually our pressure, adding pressure to keep the gas kind of trapped more. I can either move this little slider or I can slide the boxes or the blocks. Okay, inside you see the molecules in purple, and if I change the temperature, you can see some things will change. On the right side, I want you to always click graph for this lab. And on the lab paper, it'll tell you what to select for your variables on the axes or the axis, X and Y axis of your graph. So make sure you look at the lab to set this up correctly for the start. And then I want you to make sure you notice this record button. The record button will actually put a point on your graph, which will compare whatever two things you've told it to do. So here we've told it to compare volume and temperature. So we have volume on the y-axis and temperature on the x, and it put a point here to show that when temperature is 50, the volume is about 0.5 or a little bit less. When you change things then, when you change temperature, you're always going to press record and get a new point. So that's how all the things on here work, and there are going to be 2 scenarios that you test. So just make sure you look at the lab worksheet, which is a PDF you'll move into Notability, and it will tell you how to set it all up. All right, it's not as long as the last labs, not as much writing and questions, so have fun exploring with this gizmo. Thanks.